All right. Great first talk there, setting us up well for today. And so now we're going to start getting our hands dirty, right? That's what the next couple of sessions here are going to be about. We're going to have Drew Camron from Unidata come up to give us a session on exploratory data analysis, a conceptual introduction. So we are going to be using the Jupyter hub at this point. So this will be, not for your session. Great. But he's going to set us up to then be successful once we do. There you go. So let's all welcome Drew Camron.
So I'm sharing my screen now in the Zoom. Can I get a quick thumbs up? Make sure people can see and read that. Perfect. Okay. Thanks, y'all, and thanks, Russ, for that wonderful segue into our next section. No, per that save, walking up to the stage, we are not quite getting our hands dirty in the Jupyter lab just yet. But this will be a slightly different setup for our first, for this session before we dive into some data analysis. So I'm going to be covering today exploratory data analysis. For those who don't know me, my name is Drew Camron. I've been at Unidata for a few years, working primarily developing, teaching, and community building in Python. So I'm a bit of a Python head. I'm a bit of a Python freak, but don't worry, the things that I'll be covering today are not unique to Python, and hopefully you can find ways to apply these in any tool or workflow that you have. Quick shout out, the content I'm showing today was heavily adapted from some content from Nicole Corbin and Thomas Martin from a workshop we gave, actually at CSU. Also, thanks, Russ, for that wonderful highlight of sort of the history and variety of tools and software analyses you can work with in the geosciences, because today I'm not going to be coding. Spoilers, we're not going to be coding. You can, if you want, follow along in the Jupyter lab or in your own tools and explore data using some of the concepts I cover, but I'm not going to be coding with any specific language or tool as part of my talk today. However, I am going to pester my moderators, Julian and Megan, to help me encourage y'all to chat with me today. I have a lot of questions, I want a lot of feedback, and I want to pick your brains a little bit to see what you think exploratory data analysis looks like. As part of that, we will leave this session, hopefully, having a better understanding of how to navigate the data we work with and how to understand if it can help us tell our story. So let's dive in. If you'd like to speak up, please, whether you're in the room or participating remotely, raise your hand via the Zoom, drop a response in the chat, speak up here in the room. But I want to ask people, without me spoiling too much, what do you think exploratory data analysis looks like? What is a step? What is a piece? What is exploratory data analysis? I've got a hand in the room. Yes?
Learning how good the documentation is.
Yes. I would say that is a step that I think is part of our workflow we'll cover today. So for people who couldn't hear, we had learning how good certain documentation is. I've got a hand in the room.
Sanity check?
I hear sanity check. I think I have that phrase in this presentation, so I appreciate you for that. In the chat, I have understanding what the data tells us. Yes, we'll go into sort of where that line falls between the end of our story and the beginning of our story, but yes, understanding what our data tells us. Very crucial. Okay, so. Oh, I have a hand raised on the Zoom. Yes?
Yeah, so kind of following along from that, the metadata, like what are the units for the data? Where did this data come from? That kind of thing.
I don't know who spoiled my talk. I don't know who leaked the slides, but we've covered this before, and people weren't always so quick to jump straight to the real answer. Y'all might have taken a few of my slides away from me, but that's okay. We'll make it work. So yes, thank you all for your participation. These are important steps of exploratory data analysis. These are steps that probably many, if not all of you, have taken before individually or as part of your process for storytelling and science. So, if I can get my control back. I'm going to cover what we've sort of put together and pulled from other brilliant people in the space, a sort of framework for exploratory data analysis, sort of steps to take. You have taken these steps before. You may have done them out of order. You may have done them all at once. You may have done them over the course of an entire project. But we're going to sort of step through how you could save yourself some time, headache, and heartache by following a few steps earlier in the process. So for exploratory data analysis, unsurprisingly, the first step for many people will be locating some data. Let's say you've been handed, you're a lucky student who's been handed a project to tackle, or you've identified a problem you want to tackle. Step 0 is behind you. Step 1, choose your data, locate your data, obtain the data, and read it into your tool of choice. So I'll get some more feedback from the room in the Zoom. How has this looked for some people? Where have you gone to find data, to search out data? Where have you gone to obtain it? And what sort of tools have you used to read in data before you go tackling science problems? I've got a hand in the room.
By Google.
Absolutely. Yes, sometimes we need to search even for what data are available to us before we can even bother trying to get a hold of them. What are some other tools people have used? I've got a hand in the room.
My more experienced peers.
People. Yes, people are an invaluable resource. So we've heard Google and we've heard my peers and colleagues. I've got another hand in the room.
Specifically Googling threads in the name of the data.
As a Unidata employee, I appreciate this answer. We had Googling for threads plus my data or my problem. In the chat, I've got lab instruments, absolutely. Appreciate the shout out from sort of observations and real data pipelines. Any others? Hand in the room? Absolutely. So we had a suggestion for various data repositories from, say, government institutions and other resources. Okay, so yes, these are wonderful places to look for data. Step 1, unsurprisingly, look for data, find your data, use your tools of preference to read your data in. I didn't get anyone offering that. What are some tools you've used to read data into your analysis or visualization suite of choice? How do you load a file in to work with it? I've got R and Perl in the chat, some programming languages, Python and MATLAB. Wonderful, wonderful. Got a hand in the room?
For me, it's very reactive to the data that I'm working with, especially the format of the data.
Exactly.
So the tools I have are a function of the data I'm working with.
So the answer we got was being reactive, using the tools that are appropriate for my data. Yes, in exploratory data analysis, we may need to take time to work with the limitations or benefits that our particular data and formats give us. I've got a hand in the room.
Generally, I will look for an example of someone who's read that data in before and copied the way they've done it and adapted from there.
Exactly. We've got an answer for documentation, for learning what tools are available to us by following along with examples and instructions. Wonderful. Thank you all. Okay. So step 1, people seem pretty familiar with. Nothing too scary so far. Appreciate that. Step 2, let's look at our data. We're not going straight into the numbers just yet. We're not making figures just yet. But let's investigate the particular data we've decided to select for our problem. Relying on a few different potential sources of information, we want to understand the metadata that we have for our particular data set. The data about our data. We're starting to lose a little bit of meaning of that word, but basically the information that is relevant to us that might be attached to our collection of data. I'm not going to dive quite into what those are just yet because I have a bit of an exercise that will get people shouting that out to me shortly. But to get there, you might, as we already covered in the previous section, use the tools that are available to you to investigate your data set. You might use the format of the data. Maybe that data set contains the metadata within the file or within the package you've got. Maybe it doesn't. Maybe you have to check out the original source of the data or the documentation associated with it. So again, we'll come back to that one. I think that one's fun. But second step examine the data about your data, the metadata. The reason we want to take a look at this is because we may need to identify if our collection of data even can pretend to be a piece in our story to tell, can solve the problem we're looking for, can communicate the information we want to. And some of this information may tell us stop now or go ahead and continue exploring. So the third step from here, depending on the data you're working with, will be to examine the individual pieces, the individual variables, the individual scientific information contained within your data. So what is in your data set? Think forward to the science problem you want to solve. We're not there yet, but with the task you set out to tackle, with the thing you wanted to communicate to your audience, think forward and identify what pieces of information do I need to get there? What do I need to be inputs in my calculations? What do I need to show on a map? What do I need to communicate to people? Identify if these are in your data, and again, we'll take a look in a second, identify if they are appropriate to use for a variety of reasons. Note that your individual variables within some collection of data will likely have their own metadata as well, referring back to our previous step. So you might have a lot of information to glean even just about the individual variables within some data set. Okay. And then the final step, note this is not, well, I won't spoil it just yet. The final step, start to evaluate some of the relationships or potential relationships between variables within your data set. So start to look at how individual variables can be combined, calculations can be performed, or potentially start to take a look at, do some of my sort of, say, correlative statistics make sense? Is something totally off base with this data set? Start to look at that. However, an important part as we wrap up this sort of exploratory data analysis workflow to note is that we have not done science yet. All of these steps we suggest you do well before you even attempt to calculate new things, visualize information, communicate to your audience. Get this out of the way soon, do your due diligence early and thoroughly, and save yourself a lot of headache and heartache along the way. Though ideally with some of the cool tools and workflows that we'll get to show off, say this week, even if you learn much later in the process that your data was not actually appropriate, it should be easy to go back and find data to work with and make fewer changes to get you back to where you want to be. So again, this all takes place before the science. And one more time to step through it, we want to get our data, find it, locate it. We want to examine the metadata about our data set, either contained within the file itself or found somewhere else out on the internet. Take a look at the variables available to us, what they look like, and then finally start to explore how those variables relate to each other. So let's take a second and get people chatting. Oh, yeah, here you go, Max. Here's our statistical sanity check. Apologies, let this slide out. An exercise for our participants today. If I have obtained a new data set, if I've completed step 1 and steps 2, 3, and 4 are in front of me, what pieces would I need of each of those steps to say that I have fully described a data set and I feel comfortable moving forward with using it? What metadata, what variable information, and what potential connections between my variables could I want to say that I'm comfortable moving forward? Take a moment to raise your hand and shout out what you would need to know about a data set to move forward with using it. I've got a hand in the room.
Units.
I hear units. Thank you very much. Yes, I would totally agree that that is potentially valuable information to move forward with a certain selection of data. I have a hand in the room.
Missing value flag.
Yes. Am I missing data? Do I know how my missing data are identified? Yes, thank you very much. I've got a hand in the room.
Quality flags are often nice.
Quality flags, yes, I would say, if you have those available to you. Very nice, very helpful. I have a hand in the room.
If it's gridded data, how the grid is structured, like map projection or etc.
Yes, covered a lot of information with grid information. If you're working with gridded data, be that projection information in space, coordinates, etc. I've got hands in the room.
Time parameters, and I was about to say spatial parameters too.
Yes, the temporal extent of my data as well. I have in the chat listed attributes. Yes, you could pull a ton of information from collections of attributes tied to your data. I have in the Zoom chat the source of the data. Absolutely. Where does this data come from? Can I trust it? I have in the Zoom chat, I love how nearly all the answers here are standardized through CF conventions. Thank you very much. Yes, agreed. I've got a hand in the room.
I actually do a super class one of those. One is provenance.
Yes.
Provenance of data, but also the DOI. How do I cite the data?
So stemming sort of from source in the room, we had a suggestion for provenance, the sort of how the data has been handled and changed in time as it's passed hands, and how to cite the data. Very important in our space for sure. I've got a hand.
I'd like to know the extremes of the data.
Yes, the extents of the values of our data themselves. Do they make sense at all? Is there something I should be looking for, say, tied to our missing value flags, as was shouted out? In the chat, I have some fellow fans of the CF conventions. I have correlation matrix heat maps, not an expert myself, but a good place to start to understand if some of the variables in your data set are connected as you might expect them to be. I have usage rights, absolutely. Am I allowed, do I have the endorsement and blessing of using this data for any variety of reasons? I have a hand.
Version numbering, like what, are you using the latest version of the data, and are those, like the input instruments changing over time, the algorithms changing over time? Is it
Yes,
consistent?
we got the, say, version of our data set, so we can tie it to the history and documentation and relevant information around our particular data set. Absolutely. I have in the Zoom chat the time frame, so again, coming back to this sort of temporal extent. Absolutely. So we've talked a bit about some data set metadata, some individual variable information, how the variables might relate to each other. Do people feel like we've fully described our data set? I like this in the Zoom chat, the names of our variables through some, whether that be column names in a tabular file or variable names in an etcdf file, whatever that may be, what they're called. Absolutely. Okay, things have slowed down a bit. Any last minute pieces people feel like they're forgetting? Okay. So yeah, the summary we have in this presentation for sort of must-haves in exploratory data analysis, I think we touched on nearly every one. The source of the data, or in, say, more observation and lab settings, the sensors used. Remember, this information might be contained within your data set itself, or you might have to go digging for it. The projection and geographic information tied to especially gridded data, the spatial and temporal extent of your data, the variable names and descriptions and units and relevant information for the physical quantities themselves, the dimensionality of each of those variables, again, especially for gridded data, like how those are organized themselves within your data set. Are they tied to some particular coordinate and not another? Are they organized just in vertical extent, just in space and time, so on and so forth? Again, the units, the ranges of those values, and how we identify missing data. Perfect, y'all. I think we covered it all. To sort of wrap up our suggested workflow with exploratory data analysis, what is not what exploratory data analysis isn't? Exploratory data analysis is not what we're going to refer to as explanatory data analysis. So every step from here, where your goal is to communicate information, summarize new findings, create new analyses, do the science, we sort of consider that explanatory data analysis, where you explain an answer to a problem using visualization, using analysis. Exploratory data analysis, for how many letters it is close, is not the same as explanatory data analysis. So exploratory data analysis is not publication-ready figures, though we do encourage plotting in the use of exploratory data analysis. We do encourage visually identifying the relationships of variables, the extents of your data, the geographic location. Is this supposed to be in Alabama, or is this supposed to be in Costa Rica, etc. We say use visualizations, but you're not here to publish. You're not here to put this in a paper. This is, again, not rigorous statistical analysis. We encourage use of sort of statistical summaries to understand how your variables relate to each other, but you don't have to cite your process just yet. Just get to, is this good enough to move forward? And of course, exploratory data analysis is not the end of the story. Ideally, this is all done as you're planning the story. This is done at the beginning. You have much more storytelling to do with your data once you've figured out if it can work for your process. I have a quick summary of what this might look like for a few particular workflows and data styles, but that's what our next two presentations will also be on, so I will leave some room for them to cover that so that I can make us up a bit of time. We can take a look at, say, tabular data, the next of our sessions today, and what that might look like, what exploratory data analysis for that might look like, so we can imagine potentially some stations located across North America at some snapshot in time with multiple variables of observations and information captured at each of them. I want one quick shout out. What's a file format or tool you might use to interact with tabular data? Pandas. Thanks, Scott. We had a suggestion in the room for pandas, the Python package for interacting with tabular data.
Xarray for NetCDFs?
Not quite. That is potentially an option depending on how the data are organized, but Xarray is something that we'll get to more for gridded and well-structured data in space and time. Yes? Excel, a classic, absolutely. Spreadsheets. Thank you very much. All excellent ways to sort of look at rows of information, columns of information, with individually identifying information for each. I'm going to move forward for now, but thank you. So yes, what might this look like? I've got some snippets of potentially working with pandas and Python. You might have seen summaries of columns of information, identifying missing values, et cetera, et cetera. So now, just a quick looking ahead. If we have data that are equally or that are spaced in potentially X, Y, time, vertical component, et cetera, what are some tools or data formats you might use to interact with sort of multi-dimensional, well-structured data, model output, et cetera? I have a hand in the room.
GeoPandas?
GeoPandas could be good, though GeoPandas also does work well for the other. I'll ask you to offer, what was your previous answer to the last question?
Xarray?
Yes, absolutely, thank you. Xarray, a Python package for working with NetCDF-like sort of gridded data, very powerful. Absolutely wonderful tool in the space. What might that look like? A quick spoiler of sort of what we at Unidata love to espouse, the NetCDF file structure. And you might notice on this slide a few important pieces of our exploratory data analysis process captured very explicitly in the NetCDF file structure. So with that, I'm going to leave this comparison up for just what exploratory data analysis might look like in a few different file formats and data types. But I want to pause and leave some room for any questions and comments. Thank you all for your time.
Time for a quick question or two. If folks want to offer something.
I had a question.
Yeah, absolutely.
I'm not as familiar with certain terminologies but like, for instance, exploratory versus explanatory.
Mhm.
So for kind of how I envision exploratory, for instance, let's say if you have like an application that you've kind of set up and you have a bunch of different variables that you're kind of looking into, you're trying to see the different like temperatures or your precipitation, or let's say if you're looking for looking at a weather system, being able to bring everything up all at once and try and kind of see that overlay. Is that more on the lines of explanatory or exploratory?
So we have a question in the room that is, if I am using, say, an online viewer of weather data to understand a system passing through, is me pulling up those variables to investigate them, is that exploratory or explanatory data analysis? And I think it depends on the goal of your process. Yeah. If you are sort of trying to identify, could I justify to somebody else what is happening with the weather today using these data? Yeah. I might pull up the data in this particular viewer and identify, does this data make sense for me to use in justifying that to someone else? Does this data cover the extent I want at the time I want? Does it have the various individual variables that can help me explain the weather system in place? At that point, if you answer those questions with yes, it has what I need, and then you move on to, say, providing someone a forecast or providing someone an explanation, before you move on, you've done the exploratory data analysis. Once you tell someone that these variables are related in this way and that's why ... you've entered explanatory data analysis.
So within like a presentation for a class, you could shift into that, that.
Yes. So you might use exploratory data analysis to explain to the class why you picked that viewer, why you picked that data, and then use it to answer your problem. Yeah, thanks so much. Perfect.
All right. Thank you so much, Drew. Let's thank Drew one more time.
Thank you.